Hey everyone, and welcome. Today, we're jumping into a topic that, honestly, touches everything we do, environmental science. It's not just about trees and polar bears. It's the story of our planet, and really, our story on this planet.
So, let's kick things off with a pretty big question. Why all of a sudden does it feel more urgent than ever to understand our planet? I mean, what's changed? Well, the answer really boils down to the massive challenges we're facing. Things like a changing climate and the incredible loss of biodiversity.
And this is where environmental science comes in. You can think of it as our toolkit for dealing with these huge challenges. It's not just about appreciating a beautiful sunset, right? It gives us the actual tools to understand these super complex issues, everything from global climate patterns to whether the water in your local river is safe. And at the end of the day, it's the science that helps us make smarter choices for a healthier planet.
Okay, before we dive any deeper, let's get on the same page about what environment even means. Because it's not just the natural world, forests, oceans, the air. It's also everything we've built, our cities, our technology, all of it. It's the whole stage where our human story plays out. And that brings us to environmental science itself. The most important thing to get here is that it's not just one subject. It's really a team effort. It pulls in experts from biology, chemistry, economics, politics, you name it. They're all working together to figure out how our world works and, maybe more importantly, how to fix the problems when things go wrong.
All right, so to really get a grip on the environment as a whole, we kind of have to break it down into its core parts. Let's take a look at Earth's 4 key systems, the fundamental building blocks of our planet.
So you can think of our planet as having 4 major components. You've got the atmosphere, that's the ocean of air above us, the hydrosphere, which is all the water, the lithosphere, the solid ground we're standing on, and the biosphere. That's the zone where all life hangs out. But here's the crucial part. None of these systems works alone. They're all interconnected in this constant dynamic dance.
Let's zoom in on the atmosphere for a second. It's not just one big blob of air. It's got layers. Way down here in the troposphere, that's where all our weather happens. A bit higher up in the stratosphere, you've got that super important ozone layer protecting us from the sun's nasty UV rays. And then way up, the mesosphere and thermosphere are like our cosmic shields, burning up meteors and giving us those incredible auroras.
Next up, the hydrosphere. And get this, it covers about 71% of our planet. That is just staggering. It's Earth's entire water system, from the biggest oceans to the tiniest water vapor droplet in the air. It's basically the lifeblood of the planet. It keeps our temperature in check and drives the water cycle. Without it, well, none of us would be here.
Then we have the lithosphere, the literal foundation of our world. And it's not just some dead rock. This thing is alive with activity. It's a dynamic crust, broken up into tectonic plates that are always on the move. It gives us the soil to grow food, the resources for our industries, and it's the slow, powerful engine behind mountains and earthquakes.
And that brings us to the biosphere. This is the magic layer, the zone of life. We're talking every single living thing, every plant, every animal, every tiny microbe, from the bottom of the ocean to the top of the mountains. The biosphere is constantly interacting with all the other systems, cycling nutrients, keeping biodiversity alive, and even helping to regulate the very air we breathe.
Okay, so we've got these 4 amazing systems working together. Now, let's throw the most unpredictable, powerful element into the mix: us. It's time to talk about the human factor and how we don't just adapt to the world, we actively change it.
If you want to understand just how massive our influence is, just think about this one number: 40%. 40%. That is the share of energy from the sun captured by every single plant and organism on land that we, just one species, now use for ourselves. That's an absolutely mind-boggling number. It perfectly captures the sheer scale of our footprint on this planet.
When it comes to nature, we humans basically do 2 things. First, we adapt. That means we change our own behavior to fit the environment. Building a house to stay out of the rain or turning on the AC when it's hot. But we also modify. And that's when we change the environment itself to fit our needs, like building a massive dam or carving terraces into a mountainside to grow crops.
And these modifications, well, they have huge knock-on effects. Our activities are polluting our land, air, and water. We're clearing forests and destroying habitats. We're pushing species to the brink of extinction, turning fertile land into desert, and even changing the natural flow of rivers, which can lead to things like bigger, more dangerous floods.
So what's behind all this? What's driving these huge impacts? Well, it really comes down to our most basic activities. The way we get resources through mining and logging, the way we practice agriculture, the way we power our factories and our cars, and of course, the incredible amount of waste we create every single day.
Okay, that was a lot about the problem. But environmental science isn't just about doom and gloom. It's also about finding solutions. So let's totally shift gears and start looking at the pathways we can actually take to build a more sustainable future.
This pathway to sustainability isn't just one thing. It's a series of connected steps. It really starts with conservation and protection, things like planting new forests. That naturally leads to smarter, more sustainable agriculture. From there, we absolutely have to switch over to renewable energy. And finally, we have to close the loop with better waste management, learning to turn our trash back into something useful.
And these solutions don't stop there. They stretch into how we design our cities and manage precious resources like water. We're talking about things like green buildings, way more public transportation, harvesting rainwater, and smart policies like putting a price on carbon to push emissions down. Every single one of these pieces is critical to the puzzle.
But here's the thing. Individual actions and cool new technologies, as great as they are, can only take us so far. To make a real, lasting change, we need a bigger framework for action on a global scale. And that framework is all about policy. So what exactly is environmental policy? At its core, it's pretty simple. It's the set of rules and guidelines we intentionally create to manage our own impact. The whole point is to prevent, or at least reduce, the damage we do to the natural world.
So when we talk about making these policies, what are we actually trying to do? Well, the goals are pretty clear. We want to protect ecosystems, conserve resources, get pollution under control, fight climate change, and preserve biodiversity. And you know what all of those have in common? They're all absolutely essential for protecting our own health too.
Of course, saying we need these policies and actually making them happen are two very different things. It is incredibly challenging. You've got economic roadblocks, a lack of political will, rules that aren't enforced, and just the massive difficulty of getting every country on Earth to agree and work together. It's a really complex puzzle with no easy answers.
And all of that brings us to our final thought. As technology races forward with things like AI monitoring and new ideas like a circular economy, what do you think? Which future policies are going to be the real game changers? What's it actually going to take to fundamentally reshape our relationship with this one planet we call home? That's the challenge for all of us. Thanks for tuning in.